Hello everyone and welcome back. My name is Mr. Kovault, and in this video we're going to be talking about atomic orbitals. And before we get into that, please subscribe to my channel, hit the notification bell so you can be notified by other videos. Put a comment in the comment section, let me know what you think, and smash that like button. Okay, let's get into this. So atomic orbitals, uh, if you remember from a um, previous videos, we talked about the Bohr atom by Niels Bohr, and then the Bohr atom is depicts the atom like a solar system. So just like the sun is in the center and the planets revolve around the sun, so also the electrons revolve around the nucleus in different orbits, right? So that was the Bohr model, but the modern day mechanical model, the quantum mechanical model, doesn't talk about orbits, but it talks about what are called orbitals. And we talked about this in a previous video, but let's remind ourselves uh, what an orbital is. So an orbital is just an area where an electron is most likely to be found. It's what we call a probability cloud, right? So you have a certain probability of finding the electron within this area or within this space. That is what we call an orbital. So when we're talking about orbitals, you got to keep in mind that we're talking about a space, a probability space in which we have a certain amount of probability of finding the electron in that space. And so, again, it's a region where we have a high probability of finding the electron. This is a mathematical function. It is in math that is beyond what I'm going to be talking about in this video. Uh, but these orbitals fall out of the math. Comes from like wave equations and wave functions and solutions to wave equations and things like that. But we're not going to get into that. So orbital shapes, the shape of an orbital is defined as the surface, right? The surface that contains 90% of the total electron probability. So that is what your orbital is. So it's the space in which you find, in which you have 90% probability of finding the electron within that space. That's what we mean by an orbital. And so here example is an orbital. So if we look at the hydrogen atom electron cloud model, this is our hydrogen atom that has only one electron in it. Then the nucleus would be here at the center, and here is a probability map. And so this circle represents the area or the sphere, the surface in which you have 90% probability of finding the electron somewhere within this sphere here. So out here would be 10%, but you have a 90% probability of finding it in here. So this would be an orbital for the electron in hydrogen. All right, so how do we describe orbitals? In higher level classes, we would talk about what are called quantum numbers. You have your principal quantum number, and you have your other quantum numbers that we're not going to get into in this video. But each quantum number describes an orbital in some way, although one of them describes electrons, and I'll get to that in a moment. So how do we describe orbitals? So the first is energy level. That's determined by what is called your principal quantum number, and that's represented by the letter N, like small letter N. And this represents the energy level of an electron. So electrons can be in different energy levels. So the orbital can have different energy levels as well. So orbitals have different energy levels. So they could be energy level 1, energy level 2, energy level 3. We can describe them by their shape, right? So different orbitals have different shapes. So remember, the orbital is just a probability map of finding the electron within that area, like a 90% probability of finding it within that area. And so different orbitals have different shapes, and we'll see that they have pretty weird shapes, some of them anyway. 3, the orientation of the orbital. So this is where you get into X, Y, Z axes. So your orientation, the orbital can be oriented on an axis. If you know from geometry, your Cartesian, your axes, X, Y, and Z axes. So your orbitals can be on the axes. It could be on an X or Y or Z. It could be between the axes. So how it's oriented is also used to describe orbitals. And finally, 4, how many electrons are in each orbital. That actually, that's the 4th quantum number that's getting into electron spin. That's really talking about the electrons themselves, not so much the orbital. But we'll get to that in a moment. So these are like the four ways in which we would describe, say, an orbital. Okay, so the energy level, the shape of the orbital, the orientation, and how many electrons are in each orbital. So the first one, this is like what we call the first quantum number. This describes the energy level. So N, like I said, you can have energy levels N equals 1, 2, 3, 4, 5, 6, 7, and so on. We're not going to go beyond 7 in this video anyway. But theoretically, you could go on to infinity. And number 1, N1 is the lowest energy level, and the lowest energy level is closest to the nucleus. Now, this is important. This is very, very important to keep in mind. So electrons have the lowest energy, or orbitals have the lowest energy that are closest to the nucleus. So the closer you are to the nucleus, the lower the energy you have. And so this level here, if you look at this, we're representing these as circles, even though these are, we're talking about orbitals and not orbits. This is a convenient way to kind of explain this. So this here, you have N equals 1 level, energy level here. That is closest to the nucleus, and it's lowest energy. Then the N equals 2 would be the next higher energy level. And then the N equals 3 would be the next higher one, and N equals 4 would be next, and so on. And as you go farther away from the nucleus, the larger the amount of energy. So think about when you're climbing a ladder, think about potential energy. So if you're standing on the ground, then you have 0 potential energy if the ground is our reference. But as you climb up the ladder, you're getting farther and farther away from the ground. So your potential energy is increasing as you get farther from the ground. It is pretty much the exact same thing going on with the electron. So we don't talk about gravitational potential energy, but we talk about more of an electrostatic potential energy. So the farther the electron gets, the negative electron gets away from the positive nucleus, the electron grows in energy, a kind of potential energy as well. So again, the farther you get away from the nucleus, the higher the energy you have. That's important to keep in mind. All right, what about orbital shape? So we can describe orbitals by their shape. And so there are 4 different shapes that the orbitals can have. I would call these sublevels or energy sublevels. You'll hear that as well. So the first way was the energy level, and this would be the sublevel in which you would find an electron. And there are 4 sublevels that we'll be dealing with. And again, theoretically, you could have more, but the ones we're going to be dealing with is S, P, D, and F. And S, P, D, and F refer to the different shapes that an orbital can have, or orbitals can have at that level. So these are the names of the orbitals, S, P, D, and F. And we'll go over, I should say, sublevels. But the orbitals have the same names. So different orbitals have different names, S, P, D, and F, based on their shape. Okay, so let's look at some orbitals. So the s orbital shape, you can remember that s orbital is spherical, so they both begin with s. So an s orbital has the shape of a sphere, and again, the shape again of the orbital is the probability map, or the probability shape of finding the electron within that space. So the spherical shape, the orbital is centered around the origin of the three axes. So you have that axes, your coordination, your Cartesian coordinate plots, with your axes, and at the origin you have the XYZ axis, and so the s orbital is centered on that origin in space. So here's an example here. So you have your XYZ axis, and so this is your s orbital. So it has this shape. So again, this would be the probability of finding 90% probability of finding the electron within this space here, if your electron is in an s orbital. What about p orbitals? So p orbitals, there are 3 of them. And so these come about after your energy level number 1. So all energy levels will have their s orbital, has an s orbital. So n equals 1 has an s orbital, n equals 2 has an s orbital, and so on. Starting at level 2, n equals the energy level number 2, you'll now have p orbitals involved. And then we also call these sometimes subshells or sublevels. So you, at the second energy level, you'll have a p sublevel. And in that sublevel, you have p orbitals. And so the 3 orbitals, and I'll show you pictures of in a moment, are double lobed. They kind of look like 2 balloons kind of put together, or like dumbbell shape or pedal shape or something like that. And so each of the p orbitals is oriented along a different axis. So you have a p orbital along the x-axis, one along the y, and one along the z. So if you look here, here we have this orbital here. This is a p orbital. This p orbital is arranged along the x-axis, so we call that px. So px, or p sub x, that orbital is oriented along the x-axis. Py is a different orbital. It's oriented along the y-axis. So you can kind of see how this is kind of 2 balloons kind of connected together in the middle. And then you have a third orbital, or p orbital, that is oriented along the z-axis. So 3 different p orbitals arranged along different axes. And all of these orbitals kind of are together on the same set of axes. Here we split them apart, but if you can bring them back together, you'd have a px here, you'd have a pz here, and a py. So they'd all be together in this space here. They're not like separate like this. Now the next set of orbitals is called the d orbitals, and you can think of this also as the d sublevel. So d orbitals have a weird shape. They have multiple lobes. There are 5 d orbitals, and you start to see the d orbitals at energy level number 3. So the d sublevels come in at n equals 3. So remember, the p orbitals come in at n equals 2. The d orbitals come in at n equals 3. And there are 5 d orbitals at this sublevel. So you can remember d orbital, double dumbbells, or dumbbell with a donut. You'll know why in a moment when you see the shapes. So these are the shapes of the 5 d orbitals. And you can see here that they're named according to the orientation. So you can see here that this is the ZX, means that these are kind of in the ZX plane of the coordinate system. XY, these four lobes are in the XY plane, and these are in the YZ plane. So you can kind of see the different shapes. This one is a dumbbell with a donut. That's kind of weird. So these are, again, this is the probability map where you'll find electron in this energy level at this sublevel here. So if you have an electron in a d orbital, it has a 90% probability of being in this area here. It has a very low probability of being outside. So these are weird shapes. And then F, the final orbitals that we're going to be looking at, the final sublevel is the F sublevel, where it has F orbitals. And you can remember these as funky shaped because here they are. So these are the F orbitals. And again, these are mathematical probability maps of where you'll have a 90% probability of finding an electron within this space. So just think about that. So if you have an electron in an F orbital, the 90% probability of finding the electron in the lobes, but not outside the lobes. So that's just kind of weird when you think about it. Like, it has a very low probability of being between the lobes, but it has a high 90% probability of being in the lobes. So it's just weird. So again, these are the F orbitals. And so when we're talking about orbital orientation, different orbitals have different orientations, as we said. So we have the XYZ axis, and so we can identify orbitals based upon their orientation. So again, the PX orbital is oriented along the P axis, so we call it the PX orbital. And then the PY orbital is oriented along the Y axis, so we call that the PY orbital. And the PZ orbital is along the Z axis. So we can name different orbitals by their orientation, although they are in the same sublevel. So if we're in energy level number 2, then we'll have a P sublevel, and within that P sublevel, we have 3 different P orbitals that differ by the difference in their orientation in space. All right, so what about electrons in the orbital? So we have one more quantum number to talk about, and that has to do with the electrons. So each orbital can only hold a maximum of 2 electrons. And this has to do with what is called electron spin. And electron spin is not literally the electron spinning. It's something else that we're not going to get into, but it's just analogous to what's going on when you have an electron spinning. But I don't want to go too far into that. So each orbital is only allowed to have 2 electrons. One electron is called, quote unquote, spin up, and the other electron is called spin down. And those are the only 2 possibilities. Either the electron is spin up and the electron is spin down. And so when 2 electrons occupy the same orbital, they have to have opposite spins. So you can't have 2 electrons in the same orbital with the same spin. That's not allowed. And so in an orbital, you only have 2 electrons, and so those electrons are only allowed to be in that has a spin up and a spin down. So that, ladies and gentlemen, is the 4 characteristics of orbitals, or what we call the 4 quantum numbers. 4 things that we use to describe orbitals and the electrons in orbitals. So again, just to recap, we have the quantum number that deals with the energy level, right? So we have energy level, and those are represented by the letter N. So you can have N equals 1, 2, 3, 4, and so on. You also have the the shape of the orbital. That is another quantum number. And the shape of the orbital kind of indicates what sublevel it is at, right? So again, the shapes can be S, P, D, and F. So S for spherical shaped, and then P, remember, for the two dumbbells or the two balloons kind of put together and the center like tied together. So that would be different shapes. And you have the D and the F. So S, P, D, and F. The third one is the orientation, like how those orbitals are oriented in space, right, along the X, Y, Z and axis, or in the planes, right? You can have ZX plane, ZY plane, things like that. So how they're oriented in space. And then finally, you have the electrons. They could either be spin up or spin down. You can only have two electrons together in one orbital, and they have opposite spins. I hope this is helpful. I hope this was interesting to you. If you like this video, please hit that like button. Please subscribe to my channel. Hit that notification bell so you can be notified by other videos I put out. Please put a comment in the comment section. Let me know if you have any questions. Thanks for having me. Thanks for joining me, and have a great day.